Hello and welcome to Amit's Tech Sessions. My name is Amit and I'm a software architect. In this session, I'm going to talk about APIs, APIs architecture, and we'll also cover different API architecture styles which are commonly and widely used across the industry. So first, let's understand what is an API. API stands for Application Programming Interface. I generally like to explain the APIs with a front door analogy. So let's say you live in an apartment or a house. Now you are coming from outside and you need to collect uh, something from your apartment, right? So let's say you forgot your laptop and you want to collect your laptop. So you enter into the apartment from the front door and then you pick up the laptop and go back to work. Similarly, if you need data from a system, APIs are the front door. Only difference is that you cannot directly go to the data and that you cannot directly collect the data without going via the APIs. So APIs are the front door for the data which you need from a particular system. So you as a customer make a request to the API and then API provides you the data what you need. And behind the API, there would be an application running on a server. There would be a database, mostly where the data is available. Right? So in a nutshell, API is a front door for your application which is invoked by customers of your application. As a client, you make a request to the API. API is part of an application, and this application then reads the data from a database and provides you the required data in the response. So let's understand the API architecture. An API architecture is a set of rules and patterns on what methodology API will be used for its implementation. And there are different type of methodologies or styles which we will discuss in this video. An API architecture provides a set of components which are involved in building and producing an API for its customers' uses. Right? An API architecture components mostly are endpoints, requests and responses, data model, HTTP methods, authentication and authorization, rate limits, API testing and monitoring tools, circuit breakers, load balancers, etc. And there could be more as well. Now let's also understand what is an API gateway. So API gateway is much like an entry point for the requests which are made to your APIs. API gateway abstracts any complex routing capabilities away from the real APIs or the microservices in this example. It is more of a traffic manager which interfaces with the backend services. It provides a mechanism to cache the data. It also provides you authentication and authorization capabilities, versioning capability, etc. API Gateway provides a seamless experience to the customers. API Gateway is responsible to route the request to the appropriate service. Some of the common capabilities of API Gateway include authentication and authorization, request validation, metrics collection, response aggregation, and response transformation. And there are many other capabilities which API Gateway provides. There are different architecture styles for APIs which are available in the market, but the most common API architecture styles are up on the slide here, which are widely used across the industry. So these are SOAP, REST, WebSocket, gRPC, and GraphQL. And we'll discuss them one by one in the upcoming slides. So let's talk about SOAP. SOAP stands for Simple Object Access Protocol. SOAP is generally termed as a protocol and not an architecture style. However, for simplicity, I'm keeping it into the architecture styles section here. SOAP is a protocol which uses XML for messages and uses predefined contract to exchange data between applications. The interface specifications or the data models are agreed in advance between both sender and the receiver. Sender sends the message to the receiver in the form of an XML message. Receiver then performs its operation and returns the response in the form of XML message. Both request and response messages are enveloped. One of the advantage of using SOAP is that it can handle complex operations such as transaction, security, authentication, etc. The disadvantage of using SOAP is that it is very complex to understand, not very much scalable, and also not flexible for different data types. SOAP is not as widely used as of now because it is considered a legacy API architecture style. SOAP is primarily used when the data model is quite complex. So now let's talk about REST. REST is a commonly used architecture style for APIs. REST is very popular in the microservices architecture. REST is easy to implement and it uses HTTP methods. REST supports multiple types of data formats, including JSON and XML. Most of the social media websites these days are powered by REST APIs. REST is very simple to use and also simple to implement as well. It is very fast and it supports the caching of the data so that it can provide the response to the requester pretty fast. REST is also flexible to implement different message structures. Most programming languages provide frameworks to implement REST APIs. For example, in Java, you can use Spring Boot and create REST APIs. You can also use Drop Wizard in Java to create REST APIs. In Python, you can leverage Flask or Django to create REST APIs. And there are different HTTP methods as part of this REST architectural style. Get method is used to receive the data from the API provider. Post method is used to create new data record in the system. Put method is used to update an existing record in the system. And delete method is used to delete the data record from the system. The disadvantage of using REST is that it does not support complex operations, and also it does not handle errors or exceptions very well by default. So now let's talk about WebSocket. WebSocket provides the capability of real-time, bidirectional and persistent connection. WebSocket is primarily used for applications like chat messengers or real-time gaming. WebSocket is faster than HTTP because it uses a single connection and then does not need any header or cookie on every request. So it can push the data from the server to the client without waiting for a request, which actually enables the real-time and event-driven communication. If you look at this diagram, first in step 1, client initiates the HTTP connection. Server then provides a handshake that I have received the request. And now connection is established. Both client and server can send messages to each other. This communication remains active until one of the side, either client or the server, closes the connection. WebSocket is not supported by all the browsers, which is one downside of this. WebSocket does not store any connection information on either side, which means that WebSocket are not stateful. WebSocket are good for the applications where they need real-time communication on both sides, such as chat applications, game streaming, etc. So let's talk about gRPC. So gRPC is modern version of RPC, which uses protocol buffers for the communication. In gRPC, a client application can directly call a method on a server application on a different machine, similar to how you call assuming a local object. Hence, it makes easier for you to create distributed application and services. In gRPC, you define a service, you specify the methods that can be called remotely with their parameters and return types. There are two sides in gRPC, server side and the client side. On the server side, the server implements this interface and runs a gRPC server to handle the client calls. On the client side, the client has a stub that provides the same methods as the server. gRPC is common for microservices architecture, and companies like Netflix are using this heavily. gRPC supports bidirectional communication, authentication, and encryption. gRPC is also fast because it uses HTTP2 to reduce the latency and the bandwidth. One of the disadvantages of using gRPC is that it is complex to understand, and someone who is using it need to have an understanding of protocol buffers. One other disadvantage is that gRPC is not supported in all modern browser types. Now let's talk about GraphQL. GraphQL is not just an architectural style, it is powerful query language. It provides the capability of retrieving the data, what you exactly need. Right? Sometimes in REST APIs, we retrieve a lot of data from the APIs. However, we only use a few fields from the response of that API. So GraphQL is the solution to that type of problem. So you ask GraphQL APIs exactly what you need. GraphQL was developed by Facebook and it provides powerful flexibility and efficiency. GraphQL works with most server-side languages and frameworks because it has its own schema language. GraphQL has a single endpoint. GraphQL is strongly typed, which helps to ensure that data is consistent between client and server. The challenge with GraphQL is that you need to learn some complex syntaxes if you want to use or implement GraphQL. The disadvantage of GraphQL is that it does not handle errors very well by default and sometimes returns 200 even if there are errors in GraphQL layer. That's all I have for this video. I hope this was useful. If you would like to connect with me on LinkedIn or Medium, there are QR codes up on the screen. Thank you very much.